Um, hey guys, we're live and in stereo. So basically, my friend asked the yes sir if he could reduce the cost, and he was just kicked out without a reply. And tough luck. I just can't say anything about that, but okay. I only teach online, yes. Okay, so one more thing, guys. I will be conducting the MCQ session, inshallah, if God gives me the strength to do so. I will be conducting these MCQ sessions till your exam, till your chemistry exam. You need to note one thing that I will do all the sets with you from 2023 till 2002. Hopefully, I'll try my level best. I can't promise this, but I'll try to cover as much as possible, especially the latest papers, right? Now, what are these MCQs? Where are they going to be placed? And how have you collected them? Let me tell you guys a simple procedure that we've done to collect these MCQs. What we've done is, and you guys need to thank the following students. Let me tell you guys the name of the students who helped me compile these. So, let me tell you the name of those students because I want you guys to just thank them. These are the MCQs that the examiner has mentioned in the examiner report to be the most difficult MCQ or to be the MCQs that many students made mistakes in, right? Or that many students got wrong. So we have compiled it as per the examiner report, where the examiner has specifically stated that these were the MCQs where students made a lot of mistakes, or that these were the most difficult MCQs of these papers, right? So it contains IGCSE as well as O level and all of the variants, as well as the MCQs from their individual examiner reports. Now, who are the students? The students names are as follows. Number one, it's Samir Manwani. You guys need to thank him. Alishba, she compiled it. Chaudhry Ali Afnan compiled it. Fatma compiled it, and Fatma also compiled it, and Abiha Irfan helped me compile these MCQs for you guys, right? So you guys should thank all of them for to get these sets beautifully. Now, where will these sets be present? Yes, Sana Fahim also. Yes, where will these sets be present? These sets will be present, and Shamin as well. You guys helped compile the yearly papers, yes. Now, and Arshman as well. These guys helped compile the yearly papers. You are right. Now, where will these be present? There will be a link in the description, or you can even check out the link in the description of the WhatsApp groups as well as in the description of this YouTube channel, and you will find out sorry, in this YouTube video, you will find out, or any of the previous video, there will be a drive link, and all these papers would be there as we are, going through them, as well as their marking schemes. ठीक है? चलो, so बस ये बोलना था. और इसके बाद इंशाल्लाह आफ्टर वी आर डन विद ओ लेवल्स एंड IGCSE, I will also conduct a session guiding you guys for the way ahead in for your A levels, right? This booklet, this 2018 set has been shared. We will do 2023 set, 2022 set, 2021 set, 2020 set, 2019 set. All of the sets I'll do inshallah if God gives me the strength to do so, right? Now let's start off with 2018 set. As per the examiners, apparently these are the most difficult MCQs, or these are the MCQs in which a lot of students made mistakes. So let's find out what's so difficult about them. Now, when smoke particles are observed with a microscope, they are seen to move around randomly. This is called Brownian motion. What causes Brownian motion? Now, Brownian motion officially has been removed from your syllabus, but it's pretty easy. The idea behind Brownian motion is that, small particles which you can't see, small particles which we can't see, they move, they constantly move, and they bombard these large particles. They bombard large particles, and due to which you could see these large particles moving. For example, the way Robert Brown found this out was that he saw certain pollen grains which were moving on water. Certain pollen grains were moving on water, right? And he figured that the pollen grains may have been alive, but he was wrong. The pollen grains are not living things, right? Pollen grains aren't living things. So why were the pollen grains moving, or why could you see the pollen grains to move? Because they were larger particles compared to the water particles, the water molecules. So what was happening was the water molecules were moving constantly in a random motion, and because they were bombarding the pollen particles, they were, you could even say, colliding with the pollen particles that allowed the pollen particles to move in a random pattern, right? So if you talk about Brownian motion, the idea behind it is that smaller particles which you can't see, basically move the larger particles. So in this case, we see the smoke particles moving. What would that mean? That means the reason why the smoke particles are moving is because the air particles which you can't see are bombarding these larger smoke particles continuously, and that is why you could see them move. You can't see the air particles, but you could see the smoke particles because they are larger, right? So the idea of Brownian motion has now been removed, but if you were to just look at these, what causes Brownian motion? Not diffusion of smoke particles, rather it is the molecules in the air hitting the smoke particles, right? The smaller molecules hitting the larger molecules. That's the idea of Brownian motion. Sublimation of smoke particles. Sublimation is, going from a solid into a gas without being converted into a liquid. It doesn't make sense here, right? The smoke particles hitting the walls of the container, they do hit the walls of container, but that's not what causes the Brownian motion. The idea of Brownian motion, remember, diffusion is also taking place. Smoke particles are also hitting the walls of container. A and D are absolutely correct. That's what's actually happening. We know diffusion will always take place from a region of high conc to a region of low conc as long as you have a liquid or a gas, right? But realize that that's not the cause of Brownian motion. The cause of Brownian motion is smaller particles hit larger particles. That's why you could see the larger particles moving, just like you could see pollen grains moving on water, right? Because the water particles, which are smaller, they hit the pollen grains. They continuously bombard the pollen grains, right? So that was easy. Which statement describes the lattice structure of a metal? Now we know that if you talk about the metallics lattice, it's basically a lattice of positive ions and sea of delocalized electrons, right? Lattice literally means a regular structure or a regular arrangement. Regular structure or a regular arrangement. Now it says the lattice consists of alternating positive ions and negative ions. No, sir, there aren't any negative ions in a metallic lattice. You have electrons, right? The lattice consists of neutral atoms arranged in a layer. No, you don't have neutral atoms. You have a lattice of positive ions, not neutral atoms. The lattice consists of positive ions, true. In its sea of delocalized electrons, true. C is the correct option. The lattice consists of a neutral atoms. No, sorry, there are no neutral atoms. Yeah? I've always thought of myself as the cool chemistry teacher, who just comes to the class, just demolishes the paper, teaches you guys the concepts, and just leaves, vanishes. Yeah. Ore sajna. Next question. The equation for the formation of ammonia is shown. The energy level diagram for the reaction is also shown. He's told you that the energy, the EA, the activation energy, is from the reactants to the top, right? And effectively, this is how much energy is required to break these bonds. This is how much energy is required to break these bonds, 1 mole of these bonds, right? And this is how much energy is released. Now, my question to you guys is it an exothermic reaction or is it an endothermic reaction? It's obviously an exothermic reaction because energy taken in during bond breaking is less than the energy given out during bond formation. Given out is more, right? And how do you calculate the energy change, aka the enthalpy change? How can I calculate it? I know that the energy taken in during bond breaking is 250 and the energy given out during bond formation is 342. So what is the enthalpy change? What's the enthalpy change? Yes, sir. Can somebody give me it? Can calculate it, please? It's minus 92. Minus 92 kilojoule per mole. Now, some students, what they do is, and that's why B is the correct option, right? And you could even see C and D doesn't make sense because that's endo, right? Now, some students, what they tend to do is, they say that this is minus 42. So they try to be a little scientific about it. What they say is, they say 250 minus 342. That's wrong. The reason why it's wrong, they say, hey, minus into minus, it's plus, and 250 plus 342, you should circle D. That's wrong because you need to understand that this minus has already been incorporated in the formula. When you say bonds broken minus bonds formed, this minus bond formed is already incorporated into minus 342, which means that if I'm writing bonds broken, which is 250, and I'm saying minus bond formed, that just means minus 342. It does not mean that this minus is separate because bond formation is basically exothermic. That's why we put a negative sign to it. Right? So this negative sign is already added here. You don't need to do negative into negative. That's wrong. Yeah. Yeah. So the EA, the activation energy, is from the reactants to the top, And this is the energy given out during bond formation. This is the energy taken in. Activation energy is effectively the energy taken in to break these bonds. Then how will you calculate endothermic? In endothermic, same thing. If it were an endothermic reaction, let's suppose it was something like this. Let's suppose this was 342 and let's suppose this was 250, right? Then how would you calculate minus 250? How would you calculate it? Enthalpy change is bonds broken minus bond formed, right? So it would be 342 minus 250. Okay. Zainab, I'll solve all the sets. Don't worry about it. Make sense? Okay. Okay, one more thing that I want to, fix here for you guys. We know that nitrogen and hydrogen, when it gives you ammonia, is basically a reversible reaction, right? I want to fix or clarify a concept because the main idea for conducting these sessions is where can you get my recordings? It'll be posted on YouTube by the name Carboxyl. Okay, now one more thing I want to clarify here or fix your concepts is that this reaction that he's shown, that's for the forward reaction, right? So what happens in the forward reaction is I want to fix a concept or two. I want to help you guys learn a couple of concepts here. This is the graph that's been shown to us, right? This is the graph. If I talk about the activation energy, that's from the reactants to the top. And if I talk about the enthalpy change, that's from the reactants to the products. It's always going to be that. Yeah? Reactants, and these are my products. Now the question is, what if, listen to me very, very carefully, it's very important. What if, this is for the forward reaction, right? What if I say, what is the enthalpy change for the reverse reaction? Or what if I say, what is the EA, the activation energy? Draw on the graph the activation energy for the reverse reaction. Now, just think about this for a moment. If this is the graph given to me and I want, this is for the forward reaction, right? But what if I want to go back? What if I want to find out the EA for the reverse reaction and the enthalpy change from the reverse reaction? Just realize that for the reverse reaction, the products would now be your reactants, and these reactants would now be products. For the reverse reaction, if you want to go backwards, for the reverse reaction, these are now my reactants and these are my products. So what is the EA? It's from the reactants to the top. This will now be the EA for the reverse reaction. And what is the enthalpy change? It's from the reactants to the products. That'll be the enthalpy change. So you realize the magnitude of enthalpy change does not change. It'll remain 92, but now it's going to be endothermic because forward is exo, the reverse should be endo, right? And that's why it's pointing upwards. So if this was minus 92, this would be plus 92. And if this was the EA for the forward reaction, this is the EA of the reverse reaction. Right? So overall reaction becomes endo and the reverse reaction obviously, and the forward is obviously exo. Yeah, Mohammed, you could try it on your own and later on view the marking seen in the video. Yes, it's being recorded. Okay, when BiCl3 reacts with water, a white precipitate of BiOCl is formed, right? And this is the white PPT. It's a solid. That's the white precipitate he's talking about. It says which statement is correct? The reaction is reversible. Absolutely no. Why is the reaction reversible? Yeah, because you could literally see a reversible sign, you know. So that is reversible. When dilute hydrochloric acid is added to the reaction mixture, don't read more. Just wait, hold up a second. When dilute hydrochloric acid is added to the reaction mixture, if you add hydrochloric acid, that means that you are increasing the amount of hydrochloric acid, right? What will the system want to do? Remember, system acts opposite to what you do. So the system will want to decrease the amount of hydrochloric acid. Ain't that true? You've increased it, but the system will want to decrease it. How can the system decrease the amount of hydrochloric acid? How can the system decrease it? By shifting the equilibrium to the left and making more reactants. That's how it'll use this up to make more reactants. So what will happen? The equilibrium will shift to the left and more reactants form. Now it says if hydrochloric acid is added, now we know that the equilibrium shifts to the left and more reactants form. So it says more white precipitate forms. No, the white precipitate will decrease. Why will it decrease? Because obviously this was white here. But if the system shifts to the left, if the equilibrium shifts to the left and more reactants form, this white precipitate will be used up. Yeah, products would decrease, the white precipitate would decrease. So not more, in fact, less white PPT will be there. Mhm. When aqueous sodium hydroxide is added to that, this is a beautiful question. This is a beautiful question. Many students got this wrong because you need to understand that if sodium hydroxide is added, what will it react with? Think about it. What will sodium hydroxide is an alkali. What will it react with? Huh? It'll react with hydrochloric acid. It'll react with this acid right here. So what are you doing effectively? What am I doing? I am decreasing the amount of hydrochloric acid. I'm decreasing. What will the system want to do? What will the system want to do? The system will want to increase the amount of hydrochloric acid. And how will it increase the amount of hydrochloric acid? By shifting the equilibrium to the right and making more of it, right? So the equilibrium shifts to the right hand side, more HCl is made, and if more HCl is made, that means obviously more of these products are being made. So the white precipitate will increase, and that's why you'll realize that more of the white precipitate forms. So 1 and 3 are absolutely correct. C is the correct option. One of the students is saying, hey, sir, I know that 1 is correct, I know 2 is wrong, and through elimination, I could just say C is the correct option. And it's up to you. If you couldn't figure out why 1 and 3 were correct, and you just figured out 1 is correct, not 3, you could just say, oh, 1 is correct, there's no one option alone, so 1 and 3 C. And so you could be smart about these things at times. Option 3 explain कर दूं. देखो, sodium hydroxide is going to react with hydrochloric acid. So you've effectively decreased hydrochloric acid. The system will want to increase it. How will the system increase it? By using more of this to make more of this. So the equilibrium shifts to the right, more of this product would form, and therefore the white precipitate will also increase. That's why 3 is correct. Make sense? Okay. Aqueous sodium hydroxide is added to solid Q in a test tube. Okay. Aqueous sodium hydroxide. NaOH. Aqueous. Sounds good. Says a gas is produced which turns damp red litmus blue, which means the gas is a basic gas. You know, if it's turning it blue, that means the gas is a basic gas. And if you look at all the options, sodium hydroxide is a strong base, and we know that strong bases reacts with ammonium salts. Ammonium chloride ke saath it'll react with ammonium salt, and what's going to happen is sodium chloride is going to form, and the OH in the base or the alkali and the hydrogen in the ammonium ion are going to make H2O, and ammonia gas is obviously going to form. And this ammonia gas is what will turn the damp red litmus paper blue. So obviously C is the correct option. Why isn't aluminum correct? Well, we haven't in fact studied the reaction of aluminum with NaOH, have we? Right? So we don't know whether a basic gas is being released. If you just look at ammonia, ammonia is not solid. It says there is solid Q in test tube. Ammonia is literally a gas, so you can't circle that up. Sodium nitrate, NaNO3. Sodium nitrate, you've not studied a reaction in which sodium nitrate is reacting with sodium hydroxide, have you? You know, you haven't studied any of this. So you realize that probably it's not going to release that basic gas. That's why elimination method is the best method to solve these questions. Okay. Elements in group 1 of the periodic table react with water. Yeah, we know, like for example, sodium is going to react with water. What's going to happen? The sodium is going to probably displace the hydrogen in H2O. It's going to give you sodium hydroxide, and hydrogen gas is going to form. Make sense? Now it says, which row describes the products made in the reaction and the trend in the reactivity of elements? Now, what are the products? The products are metal hydroxide and obviously hydrogen gas. These are my products. So metal hydroxide and hydrogen. So C and D are wrong. Now, yes, you need to know the test for ions and gases. Yes, Ali Afnan. Now, trend in reactivity. Down the group, lithium, sodium, potassium, ba 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 ba. Down the group, what happens to the reactivity of metals, of group 1 metals? Increases or decreases? Obviously, the reactivity increases. Yeah, the reactivity increases. Why does the reactivity increase, anybody? Why does the reactivity increase? Because remember, for metals, reactivity is how quickly they can lose electron. Remember this. How quickly metals can lose electron. And when you go down the group, you'll realize that the size of the atom increases, right? So first the electron was here, now it's a little farther, now it's a little farther. So you'll realize that it is easier to remove this electrons because the distance between the nucleus and the outermost electron increases. So it's easier to lose electrons as you go down the group. That's why the reactivity increases. So trend in reactivity, you have more reactive elements down the group. B is the correct option. A is wrong. Yeah. Easy peasy lemon squeezy. Can you show the last question here? See, done. Lakir ka fakir. Okay. An inert gas R is filled with weather balloons. Which gas is used to fill these weather balloons? Which gas? Hmm. You guys should know this, by the way. Yeah, it's helium. It's helium. Everybody's right. Everybody dreams of, going and traveling in these helium balloons or whatnot. That says which description of R is correct. Now we know it's helium. Number of outer shell electrons in atom of R. How many outer shell electrons? Helium is 2 4. So it only has 2 electrons in the atom or shell, not 8. So C and D are wrong. And we know it's not diatomic molecules, it's basically monoatomic, you know, single atoms. Easy peasy. Group 7 are diatomic. And even nitrogen, oxygen, you know, hydrogen, they are diatomic and group 7. Afnan is saying, I didn't know if it was helium. Well, now you know. Now you know. A student heated copper carbonate and copper nitrate. Copper nitrate and copper carbonate. In fact, copper nitrate is no longer a part of your course. But if you want, I'll still solve the MCQs. Who knows? Later on, they may add it and I will use the same recording later on. So, copper carbonate, when and it says both compounds decompose. When copper carbonate decomposes or metal carbonate, it forms metal oxide and carbon dioxide, right? And when copper nitrate decomposes, it forms metal oxide, which is copper oxide, plus nitrogen dioxide plus oxygen, right? Do you need to know this? No, you don't. It's no longer a part of your course. But since it has been asked, I will still solve it. Right? It says which row shows the gases produced from each reaction. So in reaction number uno, copper carbonate, you get carbon dioxide. So D is wrong. And then in reaction number dos, you don't get nitrogen dioxide only, you don't get oxygen only, you get oxygen as well as nitrogen dioxide. Therefore, C is the correct option. And they have removed this. So I'll say no longer part of course, not in course. Yeah. Copper nitrate decomposition is not in your course. Yes, it's useful for everybody. I'm solving all the questions, Ghazala. Which statement about sulfur or one of its compound is correct? These are all the questions that the examiner report stated and many students got wrong. Yeah, try to do this on your own. Which statement about sulfur or one of its compounds is correct? Sulfur occurs naturally as the element sulfur. Yes, it does. It literally does in volcanoes, etc., and whatnot. So it does. Sulfur dioxide is used to kill bacteria in drinking water. No, that's chlorine. Sulfur dioxide is acidic, very much. Sulfuric acid is a weak acid. No, in fact, it's one of the strongest acid that you have. King of acids. Dilute sulfuric acid is a dehydrating agent. We don't need to know this now. Not in course. But it's not dilute sulfuric acid, it's in fact concentrated. Conc sulfuric acid is a dehydrating agent, just means it removes water. You know, you will see the use of conc H2SO4 in rusting a lot. In rusting questions, you would see that. So this is no longer a part of your course about sulfur being dilute sulfuric acid being dehydrating agent. That's why I'll just circle A. Yes, yes, Aisha, you're right. Drying agent, same thing. Ethanol can be formed by fermentation. Yes, sir. And it can be formed a reaction between steam and ethene. How is it formed by fermentation? You have aqueous glucose, you add yeast to it, you provide it a temperature of 35 degrees Celsius, anywhere from 25 to 35 degrees Celsius, and obviously you provide it with no oxygen, absence of oxygen. Yeah, and you get ethanol, C2H5OH plus carbon dioxide. Two of these and two of these. Yeah. And when you take steam and ethene, what happens is an alkene and you react it with steam. Remember, it's not water, it's H2O gas. What are the conditions for it? You need a temperature of 300 degrees Celsius, an atmospheric pressure of 60 atm, and a catalyst, which is phosphoric acid, acidified aqueous phosphoric acid, or any acid for that matter, right? Now it says, which of these processes use a catalyst? Which of these processes? It's not KMNO4. What's wrong? KMNO4 is acidified aqueous potassium magnate is used to oxidize alcohol into carboxylic acid. That's where acidified aqueous potassium manganate is used. Remember? Mm-hmm. Make sense? Okay. So which of these use a catalyst? Now, a lot of you are saying, oh, sir, C is the correct option, C is the correct option. That's wrong. C is not the correct option. Because what you'll realize is that yeast is also a catalyst. Guys, it's also a catalyst. Enzymes. What are enzymes? Yeast is an enzyme. Yeast is an enzyme. What is the definition of an enzyme? They are biological catalyst. Yeah. They are biological catalyst. What does biological catalyst mean? They are living catalysts. So they are catalyst, everybody. Is the correct option. Both are catalyst. Even yeast is a catalyst, but it's a biological catalyst. It's an enzyme, but enzymes are biological catalysts. Autism as I speak. Yeah. Khair. Which gas sample contains the smallest number of molecules? Obviously, helium is He, oxygen is O2, CO, carbon monoxide is CO, nitrogen is N2. Now, which of these would have the smallest number of molecules? The one which has the least number of moles. The one that has the smallest number of moles of molecules that have the least number of molecules. So how do you go from mass to moles? Mass equal mole times molar mass. Mass of helium is 4 grams. Moles I need to calculate. Molar mass of helium is what? 2, 4? It's 4. Mole equal 1 mole. So you have 1 mole of helium. How many moles of oxygen you have? You have 16 divided by 32 because the molar mass of oxygen is 32, sir. Mm-hmm. Junaid, छोड़ दें. Stop taking help from Google. That's what I always say. Don't trust Google with everything. You know? Yeah, Junaid, that's tough luck, kiddo. Khair, 16 divided by 32. What do you get? 0.5 moles. So we have 0.5 moles of oxygen. And then what do you do with carbon monoxide? Carbon monoxide is 12 plus 16. That's 28 divided by 28 grams, obviously. Sorry, 28 is the molar mass, and you have 28 grams of that. So it's mass over molar mass, right? 28 grams divided by molar mass. So I'm just doing it directly. Mass over molar mass. You have 16 grams divided by the molar mass. You have 28 grams divided by the molar mass, which is 12 plus 16. Nitrogen is what? 14, and 14 times 2, you get 28. So how do you calculate the moles? It's mass over molar mass. Mass is 28 grams. The molar mass is obviously what? 28. I've calculated. So this gives me 1 mole. This gives me 1 mole, and you have 0.5 moles, and this is also 1 mole. So you only have 0.5 moles of oxygen. You get what? B as the correct option. That has the smallest molecules. Because if you want to find the molecules, you just multiply this with Avogadro's constant. 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 So the one that has the least number of moles will have the least number of molecules. How to find the atoms? You will further, once you get the molecules of oxygen, each molecule of oxygen has 2 atoms, so you will multiply this with 2 further. Once you get the molecules of carbon monoxide, each molecule of carbon monoxide has 2 atoms, one C, one O, so you'll further multiply this with 2. Once you get the molecules of nitrogen, each nitrogen molecule has how many nitrogen atoms? 2. So you'll further multiply this with 2. That's how you find the atoms. Helium is not a molecule. Helium is a monoatomic molecule. You'll learn more about that in A levels. It's monoatomic. अब उसने कह दी मॉलिक्यूल ढूंढे, पर ठीक है ना, सही है. As you should say atoms, but okay. Sir, if it is diatomic, again multiply? No, we haven't multiplied anything with anything. We just want molecules. These are molecules. If you want to find the atoms, then you multiply this with 2, then you multiply this with 2, then you multiply this with 2, because each of these has 2 atoms, 2 atoms, 2 atoms. And if you are still confused between atoms and molecules and whatnot, Abdullah, I would recommend you all go over my moles and stoichiometry class, which is uploaded on YouTube, and go over the first 2 classes. Bold of you to assume I'm studying this shit in A levels. Okay, Laiba. Okay. The diagram shows a circuit used to electrolyze aqueous copper 2 sulfate. So you have the copper 2 plus ions and the sulfate ions and whatnot. And you're using copper electrodes, mind you. Now, what's going to happen? It says which arrow indicates the movement of copper ions in the electrolyte. Now, this is the negative electrode, right? That's the negative cathode and that's the positive anode. Panic. Positive is anode, negative is cathode. True? Now, if we talk about the copper 2 plus ions, where are they going to go? Are they going to go towards 1 or are they going to go towards 2? Positive ions are attracted to negative electrode. unlike charges attract. So it's going to be attracted to the cathode, not the anode, Shami. Cathode. Positive ions are attracted to negative, positive are attracted to negative, negatives are attracted to positives. Simple physics, I guess. So copper ions will go towards 2, so A and B are wrong. Now, where would it says, and the electrons in the external circuit. So where will the electrons go? You know that this is copper electrodes. And what will happen is that the copper is going to dissolve. Copper would dissolve to give you copper 2 plus ions by losing 2 electrons. Now, where will these electrons go? Obviously, the electrons have been lost at the anode. So these electrons would go like this. Da, 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 da. So they don't go from cathode to anode, rather they go from anode to cathode. And even if you have negative ions going here, still the electrons would go from anode to cathode. Yeah? So it'll take C route, not 4. 4 is the root of current, because conventional current is opposite to the flow of electrons. But that's just about conventional current, and that's physics. We don't care about that. We just need to talk about the flow of electrons, which is from anode to cathode, because the electrons are coming here, they're being lost here, da 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 da, they travel. So it's 3 and 2, so 2 and 3, 2 and 3, C is the correct option. Easy peasy. The thermite reaction can be used to produce iron from iron 3 oxide. Okay. The equation for the reaction is shown. Which statements about the reaction is correct? Aluminum is an oxidizing agent. Now, think about this. Aluminum, what is it doing to iron oxide? Aluminum is taking the oxygen, it's taking or removing the oxygen from Fe2O3. And what is it doing to Fe2O3? It's making it go into iron. What is it doing to Fe2O3? Is it oxidizing it or reducing it? It's taking the oxygen atoms from it. So is it oxidizing it or reducing it? It's reducing Fe2O3, right? Because it's taking O from it. So we know that aluminum is a reducing agent. So it's not an oxidizing agent, it's a reducing agent, right? And if you talk about iron 2 oxide, that's basically an oxidizing agent because it's giving oxygen atoms to aluminum. So that's an oxidizing agent because it's giving oxygen atoms to aluminum, making it into Al2O3. So it's making it gain oxygen. It's oxidizing aluminum. That's why it's an oxidizing agent. Yeah. I will do the 2018 complete set, and tomorrow 2019, day after tomorrow 2020, then 2023. I'll also do the 2025 MCQ paper. Don't worry. I don't know how many MCQs we're going to do. The ones that are mentioned in the examiner report, all of those. I'm doing it for the first time with you. So I don't know how many are present. Khair. So aluminum is less reactive than iron. No, sirree. Aluminum, you dumbo jumbo. Aluminum is more reactive than iron. That is the reason why it can displace iron from its oxide. Yeah, daily sessions, hopefully, inshallah. So the only way aluminum can displace iron, you also know your reactivity series by heart, but even if you did not know that, aluminum can only displace iron if it's more reactive than it, right? So aluminum is not less reactive, it's more reactive. Oh, easier. Electrons are transferred from aluminum to iron. Think about it. Are electrons being transferred from aluminum to iron? What is aluminum doing? Aluminum is a reducing agent. What is reducing agent? What is the job of aluminum aluminum is a reducing agent, right? It's a reducing agent. What's the job of a reducing agent? It gives electrons, it reduces it, gives electrons, right? Maybe you can't see it here, but because it's a reducing agent, it's going to give it electrons and reduce iron oxide to iron, right? So electrons are transferred from aluminum to iron, yes, because aluminum is a reducing agent, it will give electrons to iron oxide. The iron in iron 3 oxide is electrons are transferred, okay. The iron in iron 3 oxide is reduced, that's also correct. So 3 and 4, because iron in iron 3 oxide is reduced, it goes from Fe2O3 to Fe. Yeah, so 3 and 4 are the correct option, therefore I'll go with D. Now those of you who wanna do, sir, why did you become a snake? Okay, sorry. Those of you who want to look at the bigger picture, I'll show it to you. How, sir, how are electrons being transferred? Basically, what is happening? If you check out the oxidation states, aluminum has an oxidation state of 0 here, and here it is +3, right? So what's actually happened is aluminum is going from Al to Al3 plus by losing 3 electrons. And if you check iron out, iron is Fe2O3. So iron had a charge of 3 plus, and now here on the right hand side, it is just iron. So what is happening? Iron is gaining 3 electrons to become iron, right? So if I show you the gain and loss of electrons by breaking this equation into two half equations, aluminum went from 0 to plus 3, and the oxidation state, which means that aluminum went from Al to Al3 plus by losing these 3 electrons, and these 3 electrons were gained by the iron 3 plus ion to get iron. A Bakr is saying, why is conventional current opposite? You asked that from the physics teacher, Abu Bakr. I'm not a physics teacher. I'm sorry. It's because it was discovered later on, and then too much work had been done already. Make sense? Actually, you could have also done this question through rote learning. What do I mean by rote learning? I'll tell you what I mean by this. What you could have done is, instead of using the logical understanding of reducing agent and oxidizing agent, you could have said, hey, aluminum here, oxidation state is 0, here it is plus 3, iron is plus 3 here, here it is 0, iron is being reduced. Therefore, whatever is being reduced, I have wrote learned this, whatever is being reduced is an oxidizing agent, and aluminum is being oxidized, and whatever is oxidized is a reducing agent. So you could have done it through rote learning as well. But this is the idea of reducing agent and oxidizing agent. Yeah, makes sense. Okay, a few drops of methyl orange are added to the reaction mixture. During the reaction, a gas is produced, uh, and the methyl orange goes from red to orange. Now, you know that methyl orange is red in acid or acidic solution, and it's yellow in alkaline solution, or alkaline or basic solutions. Now, my question to you guys is, when is methyl orange orange? When is methyl orange orange? Yeah, when it is neutral, when methyl orange is neutral, obviously, when there's a pH 7, it's going to be orange, obviously. Now it says aqueous sodium hydroxide reacting with ammonium chloride. You know that ammonium chlorides are acidic salts, and when they react with sodium hydroxide, they give you sodium chloride, water, the hydrogen ion in the ammonium ion, and OH here are going to give you water, and NH3 gas is going to form. This NH3 gas will turn the methyl orange not from red to orange, rather it will turn it, the gas produced will turn it yellow because it's alkaline in nature, right? So A is wrong. Aqueous sodium hydroxide reacting with calcium carbonate. Have you ever seen a reaction between sodium hydroxide and calcium carbonate? I haven't seen any such reaction in my O levels, so I'm just going to ignore this. If I'm not left with anything, I'll go for B. I don't know. See, I'm thinking from the perspective of a student, so I don't know if I'm not left, because I haven't done any of this equation. I don't know when metal carbonate can react with alkali, because they're both bases. This is an alkaline solution, and that's also basic, and basic doesn't react. But hey, let's see. Dilute hydrochloric acid reacts with magnesium. So magnesium reacts with hydrochloric acid to give you what? MgCl2 plus hydrogen gas. And yes, sir, this hydrogen gas is absolutely neutral. It's neither acidic nor is it basic. So it'll give you the orange color with methyl orange. So C is the correct option. Dilute hydrochloric acid and sodium hydroxide. Sodium hydroxide, when it reacts with dilute hydrochloric acid, it does not produce any gas because sodium and chlorine gives you NaCl. And the hydrogen in the acid and the OH in the base gives you H2O. So no gas is formed. So C is the correct option. Yeah. 4 metals are shown. Show me the reactivity of these metals. Now, if you check out the reactivity, this is fizzing vigorously, fizzing violently, vigorously. So Y is the most reactive. I'll place 1 here. And then W is fizzing, 2 is the second most reactive. And between X and Z, which is more reactive? Obviously, Z is more reactive because you get fizzing here. And here there's no reaction. So X is the least reactive. That's how easy it is. So Y is the most, then W, then it's Z, and then it's X. But it's saying show me from least reactive to most reactive. So you have to go from X, Z, W, and Y. X, Z, W, and Y. B is the correct option. Which statement about sulfur is being repeated? We've already studied this in the previous MCQ. Sulfur acts naturally. We've already done this. It's repeating because previously what used to happen is that shouldn't the option be D for the last one? No, it shouldn't be D because it's saying least reactive to most reactive. This is most reactive to least. We have to go from least to most. That's why I read the question carefully. I just did this in the last MCQ. Dilute sulfuric acid is not a dehydrating agent. Conc sulfuric acid is a dehydrating agent, and it's not in your course anymore. It was A even before. The one before? What do you mean the one before? This one? Minha, are you talking about this one? Minha, are you talking about this one? Are you talking about this one? Yeah. It's not a gas, no? It's saying a gas produced and the methyl orange turns from red to orange. Gas, there's no gas being produced here, Minha. There's no gas being produced. Make sense? You just have to read the question carefully. This is also being repeated. It was minus 92. Solution Q. Try to do this on your own. Yeah. Solution Q is warmed with ammonium chloride. Okay. And it's warmed with it, right? Now it says in a separate solution in a separate experiment, solution Q is added to methyl orange. Which observation shows that solution Q is basic? If it is basic, that means she's probably using sodium hydroxide or potassium hydroxide, and obviously ammonia is being formed. It's a poorly constructed MCQ, but ammonia is probably being formed. Why? Because if it's basic, that means you reacted this with a strong base or a strong alkali. So ammonia is being produced, right? Sodium chloride, H2O, and NH3 ammonia gas. So a gas is produced when you warm it. A gas is absolutely being produced. So C and D are wrong. And it says when it is added to methyl orange. What happens when it is added to methyl orange? If it is saying solution Q is basic, it'll turn methyl orange yellow. So B is the correct option. Or what you could have done is you could have first eliminated A and C out, and then you could have said, hey, absolutely a gas is being produced. And then you would have checked out B. So always look at both the columns simultaneously and try to eliminate two options which are the easiest to eliminate. Red in acidic case, yes, but he's saying solution Q is basic. Why would solution Q be basic? Because it'll turn methyl orange yellow, not red. Sir, which class are you in? Really? I'm not in any class. Chill. I'm a chartered accountant by profession. It's always a flex to say chartered accountant by profession, I swear. Yeah. Try to solve this on your own. Oh, we've literally done this. B. Metal hydroxide is produced. We literally done this. It's repeating. This is also repeating. B. That was helium. Repeating again. So sulfur reactor. See, so in the previous years, uh, which subjects did you have in A levels for CA? I had sciences. Mhm. Acha, which equation represents the reaction of methane? Which equation representing a reaction of methane is correct? So CH4 plus chlorine. What happens? A hydrogen is a substitution reaction happens. Obviously, you need to provide UV light with it. But what happens is the chlorine atom tells hydrogen, hydrogen ja. Hydrogen ja. A chlorine atom tells hydrogen, hydrogen ja. Go away, hydrogen. I hate you. Go away. To hell with you. Which obviously this doesn't happen, but I just want to make it easier for you. So it says hydrogen ja. Hydrogen goes away. So you're left with CH3 and the Cl bonds instead of the hydrogen. So the hydrogen says, where should I go? And this chlorine atom says, hey, I was two chlorines. So one came here and one could, the hydrogen you could now bond with me, and HCl forms. So it's A is the correct option. Remember, this is not a substitution. You have an alkane, and alkanes don't undergo a substitution reaction. It's not possible for both the chlorines to just be added here, because it's already four bonds. And this isn't possible because you'll see isn't possible because both the chlorine atoms cannot replace the hydrogens at the same time. Why? You learned the why in A levels. It's called free radical substitution. CH4 plus Cl2, and there's nothing like this forming. There's no hydrogen or what the hell is even this? You know? Okay, this one. Pretty easy. Which volume of carbon dioxide at room temperature is formed when zero point 0.5 moles of ethane burns? So we know that 2 moles. Remember, the first step is always to convert the data into moles, and it's already given in the molar form, right? In moles form. The second step is to always use the equation. The equation says 2 moles of ethane gives me 7 moles of oxygen. So 0.5 moles, sorry, gives me 7 moles. We don't need oxygen, we need carbon dioxide. So it gives me 4 moles of carbon dioxide, right? Twice the amount. So 0.5 would give me how much? 1? And you could even do it, Zabani. You could even do it through memory. If 2 gives me 4, it's double. So zero point 0.5 should give you 1. And if you have 1 mole of carbon dioxide, convert it into volume now. V is equal to N times 24. Moles is 1 times it by 24. You get 24 dm cube. And where do we circle B? Unknown gamer, don't you know that yeast is an enzyme? Enzymes are biological catalysts. Don't you know that? It is a part of your course. Will you post this onto YouTube? Yes. Sir, आपने कैमरेज का background क्यों लगाया? Just to attract more kids, to be honest. Because I've realized that people get attracted to this background, although I hate it. Okay, chlorine displaces iodide ions from potassium iodide, right? And he's given you the ionic equation. He's not mentioned the potassium ions, which are effectively spectator ions, right? That says, what is the oxidizing agent? If I look at chlorine, what is it doing? Now, one way to figure out the oxidizing agent is from rote learning. Oh, this has the oxidation state of 0, this is -1, pure elemental state 0, this is -1. Chlorine is being reduced, therefore it is the oxidizing agent, and iodide ions are being oxidized, therefore it's the reducing agent. That's one way, right? So chlorine is the oxidizing agent. That's one way. That's called rote learning. But if you want to apply the concept, which you should have even written in your theory does not ask you the concept by rote learning. What a theory requires is conceptual understanding. How do I know chlorine is a reducing or an oxidizing agent or a reducing? Think about it. What is chlorine doing to iodide ion? Always check what it's doing to the other substance. Chlorine, iodide ion is going from I minus to I2, right? So it's losing the electron. And what chlorine is doing, it's taking the electron from iodide ions, taking electrons, gaining electrons from iodide ions. So what is it? Is it a reducing it? Is it oxidizing iodide or is it reducing iodide? Oxidizing or reducing? It's basically oxidizing it because it's taking electrons from it. So chlorine is an oxidizing agent. It's taking electrons. That's the conceptual understanding. Yeah, oh my God, Dot is so right. Dot is basically a scientist hiding behind the name of Dot. Dot is saying, sir, but if you look at the reverse reaction, in the reverse reaction, the the iodide ions, what they are doing are the iodine, sorry, not iodide, iodine is taking electrons from chlorine and is giving you iodide ions. So iodine is also an oxidizing agent because it's taking the electrons from chloride ions. Yeah. That's such a logical thing to think about. And I love that you have this question. But, sorry to bust your bubble, the reverse reaction doesn't take place. Because you know that the less reactive halogen cannot displace the more reactive halogen from its salt solution. I'm just the best. If a reaction, yeah, if a reaction, then you could have said. But yeah. But I love this question. I love it. So it's not a reversible reaction. If it was, then you could have done it. Watch the recording for talking about this. Okay. Which row shows the catalytic activity of transition? And apparently, these are the questions that students have done wrong. I just can't even imagine. Throughout the years, the examiner is saying these were the questions that many got wrong. How? How? These are literally the easiest questions I've ever seen in my entire life. Literally, I'm not even joking. You know? Oh, damn. I think something's wrong with my Apple charger. Okay, which row shows the catalytic transition element? Transition elements, are they good catalysts as elements? Yes, we've seen iron. Are they good catalysts as compounds? Yes, vanadium pentoxide in contact process A is the correct option. And see, that's what the examiner said. B was the most common incorrect option. Why? Why do you think it's not a catalyst in a compound? It is. Vanadium pentoxide, V2O5. You've literally seen it in contact process. That's when you just haphazardly circle MCQs. That's the biggest problem. The following statements are made about the metals copper, iron, magnesium, and zinc. Hmm? And says their oxides are acidic. No, they're metals. Their oxides are basic, and zinc is even amphoteric. So it's not acidic. They're basic and amphoteric. They all conduct electricity in solid state. Yes, they're all metals. Metals have delocalized electrons or mobile electrons, which are obviously free to move and they can conduct electricity because they can carry charge. Yeah, so they all can conduct. They all have high melting points. Absolutely, they do. If there was a group 1 metal, then I would reconsider this because group 1 metals normally have low melting points, right? They have weak metallic structures. But again, I'll just put, a question mark on 3. I don't know. If I were you, I'd say, hey, some metals do have low melting point. I know they don't, but let's suppose you didn't know. You were confused. So I'll just put a question mark on this. But it says they all react with dilute acids to form hydrogen. Absolutely not, because copper is below hydrogen in the reactivity series. Below hydrogen in the reactivity series. If it is below hydrogen in the reactivity series, it cannot displace the hydrogen from the acid. So 4 is definitely wrong, which leaves me with 2 and maybe 3. And if you check this out, there's no 2 alone. So 2 and 3 is the correct option, which means that yes, they all do have high melting points. The ones which are below hydrogen in the reactivity series do not react with acids. 4 isn't correct. They won't all react with dilute acids. Copper does not react with HCl or any acid for that matter, especially as far as O level and IGCSE is concerned, and even A levels, because it is below hydrogen in the reactivity series. It can't displace it. Ghazala, I'll try to cover 2018 set today. I'm going to cover 2018 set. And then tomorrow 2019 set, and then 2020 set. These are apparently the most difficult MCQs that the examiner has said. Okay. Which statement is about water is correct? Household water contain dissolved salts? Yes. Like calcium 2 plus, good for bones, fluoride ions, which are good for, your teeth and whatnot. So they do contain ions. Mineral water. That's why it's called mineral water, because it has mineral. Um, yeah. And it says water for household is filtered to remove soluble impurities. You guys might think, oh yes, water is filtered, yada yada yada. And students are even saying yes, yes, yes. Oh my god, you dumbo jumbos. Where should I jump? From which ceiling? From which rooftop should I jump and kill myself? Because you realize that how can you remove soluble impurities? You remove insoluble impurities. Yes, sir. So two is wrong. Water is treated to kill chlorine. Water is treated with chlorine to kill bacteria. Yup. Water is used in industry for cooling. Yup. 134. Correct option. 134, not 2. C is the correct option. It's used for cooling, very, very hot machines there. Water is poured on them and cools down very quickly. Mm, okay. A chromatography experiment was done to separate a mixture of 4 substances. The RF value of those substances is 0.3, 0.5, 0.8, and 0.8. 0.8 and 0.8 means what? That there's going to be one spot. So in total, how many spots are you going to have? 1, 2, 3. You must have 3 spots. Yeah. A is absolutely wrong because it's just one big fat line. There are no spots. B is wrong as well because there are 4 spots. I need 3. D and C. Now C is the correct option because you have one spot at 0.3, one at 0.5, and one at 0.8. There are two have the same RF values, so you'll just get one spot. This is wrong. Why is D wrong? Why is D wrong? Because the spot is going to, you've put the analyte here, you've put the substance to be tested here, so the spot should form here. Why would there be 2 spots? Why would there be 2 spots? You've placed the substance here. Why would it form a spot here on the left and on the right? So D is sus doesn't mean D is sus. D is just wrong. How do you get one spot here and one spot here? If the analyte is traveling like this, how does it go like poop poop? How does it go left right left right? You would have easily chosen D. Well, that's why I say don't haphazardly go over the MCQs. Poop poop. Yeah. Poop 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 poop. That's not gonna happen, is it? I just love teaching. I love bullying students. I'm joking. I love teaching. Just 3 more MCQs, 4 more MCQs, then we'll take a break before 2018 set of O levels. 4 grams of solid sodium hydroxide is added to water to make a solution with a concentration of this. What volume of water is used? Now you know N equals CV, right? Moles equals concentration into volume. Now you don't have moles, you have concentration and you need to find volume, but you could easily find the moles through the mass of sodium hydroxide, right? How do you go from mass to moles? Mass equal mole times molar mass. Mass is 4 grams, moles I need to find. Molar mass of NaOH, what is it? Sodium is 23, oxygen is 16, hydrogen is 1. What do you get, sir? 4 divided by 40, that's 0.1 moles. So you have 0.1 moles and you just plug it in here. 0.1 equals, what is the concentration? 0.2 into volume. V is equal to 0.1 divided by 0.2. V is the volume of the solution, obviously. What do you get, sir? 0.5, if I'm not wrong. 0.5 dm cube. Remember, this is in dm cube because you use the concentration in dm cube, so you'll get the volume in dm cube as well. Now, this is dm cube. You need to convert this into cm cube now. So 0.5 multiplied by 1000. That's 500 cm cube, not A, And that's why you guys get the options wrong, because you guys just hastily circle the first thing that you see with your naked eyes. Come on, just relax for a moment. Just think. This is DMQ. Why? Because the concentration was in DMQ. Why do I want to explain this again? Why do you want me to explain? This is in DMQ. The volume that you're gonna get is gonna be in DMQ. What's there to explain again? N is equal to CV. You have 0.1 moles is equal to 0.2 mole per dm cube into volume. Mole and mole cancels out, and this dm cube multiplies there, and this point 2 divides here, so it's dm cube. 0.5 dm cube is what you get, not cm cube. And once you get dm cube, you can convert it into cm cube. H2O is not a gas. You can't use V is equal to N times 24. You can find the volume of a solution by N is equal to CV. And in order to get N, you need to get the moles through this, you know. Pretty easy. If you guys still feel that your modes are weak, watch the videos on YouTube, kiddo. Stop asking me or requesting. This is unfair for me to start explaining modes and stoichiometry in between just solving MCQs. I can explain an MCQ to you, but I can't explain the entire concept to you. So please watch the recording. It's available on YouTube. You have plenty of days. Do it again. Mhm. I remember doing this experiment. I got this. You would have done the experiment wrong. Dot. Which methods are suitable to prepare zinc sulfate and copper sulfate? Well, you know that both are what? Both are soluble salts other than group 1 or ammonium. So you need to prepare them through excess method. You're going to take zinc oxide, zinc hydroxide, or even zinc in excess, or zinc carbonate. You could take four things, zinc carbonate, zinc oxide, zinc hydroxide, yeah, three things. And you could even take zinc. You could take any of this and react it with H2SO4 to get zinc sulfate, zinc sulfate, zinc sulfate, zinc sulfate, right? But for copper, if you take copper carbonate and zinc and sulfuric acid, you're going to get copper sulfate. If you take copper oxide, because acid base reactions are going to take place. If you take copper hydroxide, again acid base reactions are going to take place. But if you take copper, would it react with sulfuric acid? Would it react with sulfuric acid? No, sirree. So remember, you can't take copper metal to react. Why? Because copper is not, it's less reactive than hydrogen in the acid, so it can displace the hydrogen. So it says which are used to take both. Which methods are used for both? Remember, both. So this is reacting the metal oxide with warm dilute sulfuric acid. Absolutely, you could do it. Metal oxide, both metal oxides can be used because acid-base reaction is going to take place. Reacting the metal with dilute, no. Because for both, it will work for zinc, but it won't work for copper because copper will not react with the acid. So 2 is wrong. Reacting the metal carbonate, yes, you could use both metal carbonates. So 3 is correct. 1 and 3, that's fine. C for sweet, that's correct. Sir, imagine is a teacher learning from you. Probably. I've taught teachers from Bangladesh who were PhD in chemistry because teaching is not about the knowledge you have. Teaching is just about delivering. In the previous session, there was a gold medalist PhD teacher who started teaching O levels and IGCSE, and she took my lessons. And it's something to be proud of and to be grateful for. I'm not praising myself. I'm just saying there's no shame in learning from other teachers even. So it's fine. There's no shame in learning. You can always learn. And she's going to become a great teacher one day. Khair. Which statement about water is correct? It's just repeating. They dissolve. They don't, and they're not used to remove soluble. Da da da. 134. It's just repeat. It hasn't said it, has it? What's the duration of the course time? My O level course is always for 4 months. Always. You know, always. Sir, how can we contact you personally? This is my number. +92 333 5694 666. Suleiman Khan. Oh. Do. Hmm. Yeah. इतनी हसी जिंदगी है ये होठों पे जैसे कहानी है सदा यहाँ किसी का ठिकाना है उनकी रवानी में जाना है। खुश बहारों में हर सू रंग है बिखेरा, प्रीत का सहरा ये है एक पल का ढेरा, एक दिन बिखरना यहाँ, दिल भी कहीं है पहाड़ों में, थोड़ा सा तो दिन किनारों में। या ओके, चलो 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 रिलैक्स करें थोड़ा सा। बिग फैन सर, थैंक्स। पछ तो बस यार, थक गया हूं मैं। You guys can try to do it on your own. I'll come in 1 second. I'm drinking water. Yo, yo, yo. Abdullah, yaar, my story is just filled with topsy-turvy thingies. So just छोड़ दे मेरी story फिलहाल. I've talked about my story multiple times, but I'll talk about it some other day. Maybe in the farewell class. बस ना यार, बहुत दफा story सुना दी है अपनी जिंदगी की. It's time to focus on your lives. Yes, sir. Okay. I don't know why these questions. Okay, now I'm gonna go very quick because I am tired. I'm on 3 hours of sleep. Those of you who can't keep up, you guys can watch the recording later on. I'm gonna just drop a message on Instagram and I'll follow you back because normally follow all people with mutuals, but if I don't, then just drop a message. I'm your student. I'll give you a follow right away. Okay. Khair, now I'm gonna go very quick. Ready, guys? Are you guys ready to, to keep up with the pace? Keeping up with the card. Sorry. Are you guys ready to keep up with the pace? Keeping up with Sir Suleiman? Yes, ready? I'm gonna go and I'm gonna blaze through these MCQs. I'm gonna blaze through them. Ready? Okay. Magnesium oxide has a high melting point. Why does it have a high melting point? Because magnesium oxide is an ionic compound, right? It has strong electrostatic force of attraction between oppositely charged ions. And so this thing is used inside furnaces. Okay, great. Because blah, blah, blah. Why does magnesium oxide have a high melting point? Because it has metallic bonds? No, magnesium oxide does not have metallic bonds. It's an ionic compound. Magnesium has metallic bonds, not magnesium oxide. It has strong forces between its molecules. It does have strong forces, but not between its molecules, but between its ions. So B is wrong. It is simple molecular substance. No, it is giant ionic lattice. GIANT, giant ionic lattice. C is wrong. It's an ionic compound. Yes. Two properties of and obviously ionic compounds have strong electrostatic force of attraction. Two properties of a metal are given. It's malleable and conducts energy. Which properties are due to layers of positive ions being able to move over each other? Layers moving are the layers moving are result or are the reason for malleability. Electricity has nothing to do with layers moving, it has to do with delocalized electrons. So it's one only, not D. Next, what are the relative formula masses? Formula masses literally means MR, but for simple molecular substances you call it MR, but for ionic compounds you use the term formula masses. But in practicality it's just the same thing as MR, right? But it's just used for ionic compounds because MR means relative molecular mass, and you don't have molecules for ionic compounds, right? That's why he's used the word relative formula mass, right? That says 1 mole of what is the relative formula mass of 1 mole of solid magnesium? You could check that out into the periodic table. That's 24. So 12 is wrong. 12 is the proton number. Please realize that the bigger number is the formula mass. And 1 mole of gaseous chlorine. Chlorine is Cl2. So how do you calculate the MR for it? It's 35.5 multiplied by 2 because you have 2 Cl. So for one, it's 35.5 multiplied by 2. How do I know 35.5? Because that's given in the periodic table. 71. So it's 24 and 71. C is the correct option. Boom, boom, boom. Complete the combustion of hydrocarbon, blah, blah, blah. When zero point 0.1 mole of uh, pentane is burnt, which volume of carbon dioxide is made? Now, you need to find carbon dioxide. The first step is to convert the data into moles. It's already given in moles, and then is to use the equation. 1 mole gives you 5 moles. So 1 mole gives me 5 moles of carbon dioxide. So zero point 0.1 mole of hydrocarbon would give me how many moles? 0.5 moles of carbon dioxide. And then convert it into volume. V is equal to n times 24. You have 0.5 multiplied by 24. That gives me what? 12 dm cube. Done, dusted. D is the correct option. Next, electrolysis is used to plate a metal, electroplating. He's talking about electroplating, a metal statue with silver. Now, where should the metal statue be? It should obviously be at the negative cathode. Panic, positive is anode, negative is cathode, right? This should be the statue. I'll just, even label it somehow. And why should the cathode be the statue? Because the silver ions are going to be deposited at the negative electrode, right? So the silver ions are going to be deposited at the negative electrode because negatives are going to attract these positive ions, right? So that's why it should be the cathode, not the anode. It's pretty logical. If it's the anode, then you know that the positive ions are going to go towards the cathode, so the silver ions will always deposit at the cathode, so you need the cathode to be the statue. And this positive electrode, this anode, should obviously be silver, right? So you should have an electrolyte containing silver ions, and you should have the anode, which is silver. So the statue should be the cathode, not the anode. And the electrolyte, it's either silver nitrate or silver chloride. You're going to go with B, not A. Why? Because they've poorly constructed this MCQ. Silver chloride is not aqueous. You know your solubility rules. Silver chloride is a solid, so they've just put aqueous to confuse you guys. A is wrong. Which statements, and you know that solid silver chloride cannot be used as an electrolyte because there are no free moving ions, there are no mobile ions. Next, which statements about endothermic is correct? In endothermic, energy is taken in from the surroundings, yes, not released, that's in exo. And the temperature of the reaction mixture falls, yes. In endothermic, everything cools, remember, everything cools. Reaction mixture, everything and anything cools, and in exo, everything gets hot. So if it cools, the reaction mixture temperature should fall. 1 and 3 is the correct option. Next, bismuth chloride is added to water reaction, which increases the mass of the white precipitate. If you add more water, the system will want to decrease the amount of water by making more of the products, and therefore the equilibrium shifts to the right. So if you add more water, yes, the white precipitate does increase. Absolutely, sir. Adding aqueous sodium hydroxide. If you add aqueous sodium hydroxide, it'll reduce HCl, and the system will want to increase it. How will it increasing? By making more of it. So if it makes more of the products, the white precipitate again will be made, and the will increase, right? So 1, 2, both are correct. Then adding dilute hydrochloric acid. If you add hydrochloric acid to it, the system will want to decrease it. And how will it decrease it? By shifting to the left. So the white precipitate will decrease. So 1 and 2 are going to give you the white precipitate. Are going to give you more, increase the mass of white precipitate. So 1 and 2, where is the correct option? A. Many reaction involves oxidation and reduction. Now it says acidified manganate ions change color from colorless to purple. No, it's from purple to colorless. It's pretty simple. Kuch bhi nahi hota. They've just jumbled up things for you guys. All reactions that involve oxidation also involve reduction. Absolutely, that's correct. Oxidation, redox reactions are those reactions in which reduction and oxidation both take place. It's simultaneously happening. If something's losing electrons, the other thing will gain electrons, right? So yes, they do. And you guys might think, oh sir, but when we are doing this, sodium ion in electrolysis gains an electron and becomes Na, and chloride ions, they lose electrons and become Cl2. Sir, here only reduction is happening, here only oxidation. No, you are basically talking about half equations. Half equations do not represent reactions. Remember, half equations just talk about the individual gains and losses of electrons. But if you look at the entire reaction, if you add these two up, there's gain of electrons and there's loss of electrons. So realize that half equations are not the complete reaction. They're just individual gains and losses of electrons. Right? So during a reaction, oxidizing agent lose electrons? No, they gain electrons. That's how they oxidize the other thing. Reduction is the loss of hydrogen atoms? No, it's the gain of hydrogen atoms. These wrong. Insoluble salts are prepared by reacting aqueous solutions of soluble salts. A precipitate forms. Which pair of solutions are going to form precipitate? Barium chloride and nitric acid. Barium chloride is barium 2 plus chloride ions. Nitric acid is the hydrogen ion and the nitrate ion. If you add them to a beaker, nothing is going to happen because nothing is insoluble. Barium nitrate is soluble. Barium chloride is soluble. Hydrogen chloride is soluble. Hydrogen nitrate is soluble. Everything is soluble. Or hydrochloric acid or nitric acid, whatever. And then barium chloride and sulfuric acid. Now barium chloride and sulfuric acid means you have the barium 2 plus ions, the chloride ions, and you have sulfuric acid H plus and SO4 2 minus ions. And yes, the barium 2 plus ions are going to come into contact with the sulfate ions and they're going to make a white precipitate. Barium nitrate and nitric acid, nothing is going to happen. Barium nitrate and nitric acid is barium 2 plus and NO3 1 minus and H plus and NO3 1 minus. No precipitate is going to form. Yeah, barium nitrate and sulfuric acid, yes sir. Barium nitrate means barium 2 plus ion, nitrate ions, and sulfuric acid is the H plus ion and the SO4 2 minus. If you add this two, if you mix them together, the barium ion is going to come into contact with the sulfate ion and make a white precipitate. So 2 and 4 are correct, therefore C is the correct option. Next, which property shows an increasing trend in the elements from group 1 to group 7 across a period? So you're going from group 1 to group 7 across a period. Boom, shakalaka. So the shell number remains the same. Ability to form anions, yes, that increases because metals lose electrons, they make cations, and non-metals, gain electrons and they become anions, right? So ability to form anions absolutely does increase. Metallic character decreases, it does not increase. We need to check out what's increasing. Metallic character decreases. You have metals on the left and non-metals on the right. So left to right, metallic character decreases, non-metallic character increases, right? Number of electron shells, they remain the same. It doesn't increase. Across a period, electron shells are the same. Period tells you the number of electron shells. So reactivity with water actually decreases. Metals react much faster with water than non-metals, right? Like sodium plus water, explosive reactions. Whereas if we talk about chlorine plus water, it's basically, a reversible reaction, which you'll learn more on in A levels. Next, the diagram shows alloys. Which statement about alloys is correct? Alloys can only be formed by mixing copper and iron with other elements. No, it cannot only be formed because you have other elements as well. So A is wrong. High carbon steel are soft. This is no longer a part of my course, but high carbon steels are normally hard. Why are they hard? Because you have more carbon atoms. So the layers cannot slide over each other even further. That makes them more hard. In an alloy, there is attraction between positive ions and a sea of electrons. Yes, because alloy has metals. Uh, Sir, I'm joining different chemistry live stream on YouTube and sending your link. I love it. Okay, the alloy brass has a chemical formula. Thanks. The alloy brass has a chemical formula. No, alloys are mixtures. It's a mixture of metal with other elements, so it does not have any chemical formula. Brass is just copper plus what? Tin or zinc? Copper plus tin, not zinc. Yeah, that's wrong. The list shows the position of X in a reactivity series. X is less reactive than iron but more reactive than copper, right? That is electrolysis of solid metal oxide. How can you extract X? We know we can extract any element from its ore through electrolysis, but not of solid metal oxide. You need what? Molten. Not solid, you need it in the form of molten. So one is wrong because it can be used as an electrolyte. Heating the metal oxide with carbon. Yes, you can heat it with carbon because carbon can reduce iron, and if it's below iron, you can also take carbon and reduce X with it, right? So 2 is absolutely correct. Heating the metal oxide with copper. With copper, nothing is going to happen because copper is less reactive than X. So copper will not be able to displace X from its oxide. Pretty easy. 2 is the correct option. You need to know your reactivity series. Which statement about vegetable oil and margarine made are correct? Vegetable oil is a liquid, it's unsaturated, and margarines are a solid and it's saturated. Remember, alkene to alkene. Remember this? You added hydrogen, nickel solid, and provided a temperature of around 100 to 200 degrees Celsius. Yes. So this is both are liquid at room temperature. No, one is a liquid, one is a solid. Margarine is like butter. That's like butter. Both occur naturally. No, sorry. You basically make this. Margarine has the higher melting point. Absolutely, it does have higher melting point because you realize the greater the number of electrons, the higher the melting point. So C2, why am I saying C2H6? I shouldn't say C2H6, but margarine is saturated, right? Because it's saturated, it'll have two more hydrogens. So it'll have, it'll obviously have a higher melting point. And even if you did not know that, vegetable oil is a liquid. It has already melted. It is already melted. Margarine is solid, which means the melting point of margarine is absolutely greater than vegetable oil. Why? Because it's a solid. You need to heat it to melt it. And this is already a liquid. It has already melted at room temperature and pressure. So margarine absolutely does have a higher melting point. Vegetable oil has fewer carbon-carbon double bonds. No, it has more carbon-carbon double bonds. It's unsaturated. Margarine is saturated. You need to know. Yes, margarine is a part of your syllabus. Thanks, Osama. Hashtag no homo. Thank you very much. Okay. It is. When heated, magnesium reacts with oxygen, Mg plus O2, gives me what? It gives me MgO, brilliant white flame that you see in Harry Potter. A student investigates the change in mass that occurs. He is given a balance, and it says a white powder forms. Remember, a white powder is forming. Okay. A student investigates the change in mass during a reaction. So if he's investigating the change in mass, he obviously needs a balance. Now it says he's given a balance and 3 sets of apparatus. Which sets are suitable for this investigation? Well, if you heat this up, powder is going to form and then you could weigh it on a top and balance. So 2 is absolutely correct. Air, oxygen is incoming from here. You have magnesium here. They're going to react. MgO, white powder is going to form. And you could literally place this on a top and balance and measure it, right? Or on an electronic balance. Here, you have a crucible. You're heating it. Yes, oxygen is inside this crucible. MgO is going to form. And you can later on measure it with a balance. The problem with 1, so 1 and 3 can be used. The problem with 1 is If it's burning magnesium and you've held it only by metal tongs, the powder is just gonna go and it's just gonna, it's gonna just disperse everywhere. It's just gonna, gaya, kahin idhar gira, kahin udhar gira. How do you measure it on a top and balance? Some powder may be on the left, some may fall on the right. How can you actually dictate where the powder is gonna fall? Here, they're gonna be in this safe zone. Here, they're gonna be in the safe zone and you can measure it. But here, the powder can, because it's already burning magnesium. So when magnesium oxide forms, the powder is gonna form here. It's just gonna be thrown here and there, here and there. So it's not very accurate, is it? Right? So which sets of apparatus are suitable? Suitable is the correct word for it. So which are suitable? It's 2 and 3, not 1. Because how do you get the powder to fall exactly on the balance? You can't, right? So it's 2 and 3. C is the correct option, not A. One atom of element X and two atoms of element Y form an ionic compound. So one must be a metal, one must be a non-metal. You have X as metal and Y as non-metal, right? So X is calcium, calcium makes a 2 plus ion, and if Y is chlorine, chlorine makes a 1 minus ion, the chloride ion. And for one calcium 2 plus, how many chloride ions do you need? 2 to balance the charges, right? Or you could write the formula CaCl2. For one calcium, you actually needed 2 chloride. So for one X, you actually needed 2 Ys. A is correct option. B is wrong because for one calcium ion, you only need one oxide ion. That's why the formula is CaO. C is wrong because for one sodium ion, you just need one chloride ion. That's why it's NaCl. D is wrong because for one oxide ion, you actually in fact need two X's. You need two sodium ions. So you need two sodium ions for one oxide ions. He's saying I need one X and two Ys, not two X and one Y. So D is wrong. An element with higher melting point forms an oxide. That is an element with high melting point. Can the element be ionic? Have you heard about ionic elements? No. Ionic compounds exist. There are no such thing as ionic elements. Simple molecular, yes. Hydrogen, hydrogen, like your what am I saying? Chlorine, bromine, iodine, they're all simple molecular substances, right? But and they're all elements. They're simple molecular, but they're all elements because they have one type of them. But do they have high melting points? No. Why? Because they're simple molecular substances with weak van der Waals forces, right? So D is wrong because they don't have high melting points. Now between A and C, A is if it's metallic like metals like magnesium, it has a high melting point. So if it reacts with oxygen, it'll form MgO. And it's saying it forms an oxide that is gaseous at room temperature. And MgO is a solid, it's not gaseous. Although magnesium has a high melting point, but MgO is not gaseous, it's a solid. Now, what do we mean by the only option left is giant covalent? And I'll go with that, but you need to understand that giant covalent. Which giant covalent are we talking about? We're talking about graphite. So if you take graphite, if you talk about graphite, that's carbon. It has a high melting point, and when it reacts with oxygen, it gives you carbon dioxide, which is a gaseous oxide at room temperature and pressure. It's not diamond, it's actually graphite. Mm-hmm. खत्म होने लगी है क्लास, बस आधे एमसीक्यू रह गए. Which element explains why aluminum is malleable? Because the layers can slide over each other. So the layer of cations can slide over each other, over one another. Absolutely correct. The layers of cations. Cations means what? Positive ions, right? Aluminum layers of electrons. There are no layers of electrons. The electrons are delocalized. It has weak bonds between protons. No, it has strong bonds between. Malleability has nothing to do with bonds. But if you talk about the bonds, it has strong bonds between a lattice of positive ions and a sea of delocalized electrons. Aluminum is covered with a layer of unreactive aluminum oxide. That's true. That's true. But does it account for malleability? No. How do you know magnesium oxide is a solid? I know because I've taught it. Metal oxides are usually solids. Which statements about endothermic, and even if you did not know, where it go? Where it go? A white powder. No, even if you do not know, it's written in the above question. A white powder of MgO forms. Powder is a solid. Even though it's a powder, it's a solid. Which statement is about endothermic? We've done this. Energy is absorbed and the reaction mixture falls. The temperature of the reaction mixture falls because endothermic, everything gets cooler. Temperature, mixture, shixture, thermometer, whatever. No, Samir, I've explained this in a lot of detail. Just for now, I can't be bothered to explain the concept again, but your teachers have taught you wrong. In endo, everything gets cooler. Reaction mixture, thermometer, beaker, whatever, everything gets cooler. Yeah. And in exo, everything gets hotter. Reaction mixture, blah, blah, blah. Just know that for now, please. You know, the question doesn't state What do you mean the question doesn't state? 1 and 3 is the correct, correct. We've done this. What do you mean, Ismail? Which question are you talking about? Doesn't mention it. So the question below it doesn't mention it. It's a powder. No, I'm saying I know it from the above. Even if you did not know it, you could have, found it out through an MCQ, solved while solving MCQs. So if your concept wasn't correct, you now know that magnesium oxide is a solid, even it's written in the MCQs. You know, but you should know that. Solid ammonium chloride is heated. The gas is ammonia. So if you have ammonium chloride and it's saying the gas is ammonia and hydrogen chloride form. Okay, great. And if it's just being heated, it's being decomposed. So probably it's endothermic. And this is reaction one. It says ammonia gas is mixed with hydrogen chloride gas. The same ammonia gas is mixed with hydrogen chloride to give you what? Solid ammonium chloride. So it's a reversible reaction, right? He's saying this is reaction one. He's saying this is reaction two. That says, which statement is correct? Both reaction 1 and 2 are exothermic? No, that's not true, because if in a reversible reaction, if the forward is endo, the backward must be exo, right? So they are not both exothermic. They can't be. Reaction 2 is reversible. Reaction 2, absolutely, it is reversible. How can reaction 2 be reversible? You just heat ammonium chloride, it'll go back into reaction 1. Heat it. So it is a reversible reaction. B is correct. The equation for the reaction is NH5. NH5 is no, there's no such thing as NH5. Ammonium ion is NH4 plus. So it's NH4Cl, not NH5Cl. C is wrong. The three substances involved in the reaction have a simple molecular structure. The three substances, yeah, no, they don't, because ammonia is a simple molecular, hydrogen chloride is simple chloride, ammonium chloride is an ionic compound, ammonium ion and a chloride ion. There's strong electrostatic force of attraction between oppositely charged ion. How do I know it's reversible? The question has stated it. You could go from this to this and this to this. This is what a reversible reaction is. Going from reactants to products or products back to reactants. He's literally stated it for you. Read the question, please. Okay. Next, in a closed flask, gas Q and R are at dynamic equilibrium. Delta H is positive, which means the forward is endo and the backward is obviously exo, right? Positive means endo. Okay. What would shift the equilibrium to the right? Adding a catalyst? No, catalyst has no effect on the equilibrium. Decreasing the temperature. If you decrease the temperature, it favors exo, and exo is the reverse reaction, so the equilibrium will shift to the left, not to the right. Increasing the pressure. Increasing pressure favors fewer moles of gas, and fewer moles of gas are on the left hand side, so the equilibrium shifts to the left, not to the right. And the only option left is D. But let me explain D. D says increasing the volume of the flask. Now think about this. This is very beautiful. It's a beautifully constructed MCQ. Because if this was the flask before, now it's this was. Now if you increase the volume, what happens to the pressure, everybody? Increasing the volume. What does increasing the volume do on the pressure? The molecules, they are now far and apart, and obviously the pressure obviously decreases. Increasing volume, you know your physics. Increasing volume decreases the pressure, and decrease in pressure favors how many moles of gas? More gaseous moles. And more gaseous moles are on which hand side? On the right hand side. There are 2 moles here and 1 mole here, and that's why D is the correct option. So this is the idea behind it, but you could have even done it through elimination method. Okay. Which reaction is a redox reaction? Now, magnesium is going from an oxidation state of 0 to +2. And here, chloride is -1, hydrogen is +1. And here it's -1 and hydrogen is 0, right? Because it's in its pure elemental state. So this is clearly a redox reaction. Displacement reactions are redox reactions, right? So you know the oxidation states. In pure elemental state 0, pure elemental state 0. And in a compound, this is -1, that's +1. This is +2, because in a compound, magnesium chloride, magnesium has a charge of 2 plus, Cl is 1 minus. That's why the oxidation state is the charge on the ion. That's +2 and that's -1. Yeah. Sir, your Insta ID, wanna ask about my Insta ID is at SULLI_KHAN Sully underscore Khan shakalaka boom boom. This is an acid-base reaction. That's an acid-base reaction. That's an acid-base reaction. And you'll realize even if you figure out the oxidation numbers for it, they'll all be the same on the left and right. See, this is +2. Carbonate as a whole is -2. I'm just talking about whole. Hydrogen is +1. This is -1. This is plus 2, this is minus 1, this is plus 1, this is minus 2, that's minus 2, that's plus 4 here, and carbon here is also plus 4. Let's not talk about carbonate as a whole. That's plus 4, that's oxygen is minus 2. Same, the oxidation states on left and right are the same. Why would it be C? Magnesium is plus 2 here, minus 2 here, plus 1 here, minus 1 here, plus 2 here, minus 1 here, plus 1 here, minus 2 here. The oxidation numbers are the same. Don't look at oxygens, Jaisha. Jaisha Mariam, don't look at oxygen's gain or loss. I've always said never use oxygen's gain or loss for such equation. This is an acid-base reaction. If you check the oxidation numbers, to be 100% sure, always check the oxidation numbers. How do you check oxidation numbers? You need to watch Redox, Abdullah Nasir. I can't do anything about it. Watch Redox. There are certain rules to calculate the oxidation numbers. It'll be uploaded on YouTube. You could check it out. It'll be uploaded on my YouTube. Go watch Redox reactions. You know, Acha. There are three types of reactions in the world: precipitation reactions, redox reaction. You have like your acid-base reactions, and you have thermal decomposition. Four type probably. So redox, if it's a precipitation reaction, acid-base reaction, or a thermal decomposition, it can't be redox. Three separate mixtures of a solution and a solid state are made as shown in the table. The mixtures are warmed. In which mixtures does gas form? Sodium hydroxide and ammonium chloride. We know it forms ammonia gas, and I've shown it to you multiple times throughout this class now. So it forms ammonia. Strong base reacts with acidic salt. You know. Ammonium chloride reacts with sulfuric acid. The reaction doesn't happen because this is also slightly acidic and that's also an acid. So acid does not react with slightly acidic things. It's not going to release anything because the reaction isn't going to happen. So A and C are automatically wrong. And because D is wrong, since gas is going to be released here, C and D were automatically wrong in the first one. And in the second one, you'd realize that C is wrong and A is also wrong. So B is the correct option. This reaction happens, this doesn't happen. And magnesium plus sulfuric acid gives me what? Magnesium is going to displace the hydrogen in the acid, MgSO4 is going to form, and H2 gas is going to form. So a gas definitely does form. Ammonium chloride is an acidic salt, not just a salt. Yes, Iman, it is an acidic salt because of an extra hydrogen ion. And that is the reason why it reacts with strong bases. It's an acidic salt. It's slightly acidic. That's why it reacts with strong bases. It doesn't react with weak bases because it's not an acid. It's an acidic salt. Salts can also be acidic, Iman. Make sense? Why wouldn't gas form with this one? Because there's no reaction of ammonium chloride with sulfuric acid. How do I know it? Because I know this is also acidic and that's an acid. Just like base would not react with a base, this is acidic and acid. They won't react. Yeah. No, ammonium salts are slightly acidic. They can't be basic because ammonium salts have an extra hydrogen ion. Yeah. Group 1 metals lithium, sodium, potassium show trend in their melting points and in their reaction. Melting points increase or decrease? You just need to know the melting points decrease obviously because the metallic lattice weakens as you go down the group since the charge to volume ratio balki chhod de. You just need to know it decreases. I have explained this in my live class, but you just need to know it decreases, right? And what happens to the reactivity? The reactivity obviously increases because it's easier to lose an electron. So reactivity increases, melting point decreases. You need to know these things. So melting point decreases and the reaction with water becomes less vigorous or more vigorous? Less vigorous or more vigorous? Obviously more vigorous because down the group reactivity increases. Which statement is correct? Alloys can only be formed. No, not only. They can be formed by this, but not only. High carbon. This is just repetition. Is alloy in an alloy? There is a reaction. There's an attraction between positive ions and sea of electrons. Yes, because there's a metal in it, and the react. Remember, alloy is a mixture, and mixtures have the same properties as its elements. So whatever the mixture is made up of, it'll have the same properties. Alloys will also conduct electricity. It'll also have a high melting point, and da 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 da. Brass doesn't have a chemical formula, it's just a mixture of copper and tin. There's no chemical formula for it because it's not a compound. Yes, alloys will obviously contain at least one metal. That's true. It's a mixture of a metal with other elements. The other elements can be metals or non-metal, but there must be one metal. Which compound has the empirical formula which has the greatest formula mass? So calculate the empirical formula. C2H6, can they be divided by 2? What do you get? CH3 when you divide this by 2. C4H10 divided by 2, what do you get? C2H5. That's the simplest whole number we can get. C5H10 divided by 5. So you get CH2. C6H6, you get CH by dividing it by 6, because we need a simplest whole number, right? Now, which one would have the greatest formula mass of its empirical? See, that's the thing. You guys don't read the question. Everybody's saying D. Why are you guys saying D? It's B, yes, because it's saying which of these would have the greatest formula mass for its empirical formula. You don't need to check the molecular formula. You have to, select between these four. So between these four, it's B, because it has the most carbon atoms. So it's 12 times 2 plus 5. Brass, isn't brass copper plus zinc? Yeah, it's copper plus zinc, my bad. Bronze is copper plus tin, sorry. It's copper plus zinc, my bad. It's copper plus zinc. Yeah, you are right. You are right. Which statement about vegetable oil and margarine correct? We've literally done this. Margarine has a higher melting point. Two large molecules P and Q have the same linkage. P and Q occur naturally. P occurs naturally, but Q doesn't. Now, if you look at which of these occurs naturally, which of these occur naturally? P, which can be P? Which of these can be P? A, B, and D can be P. Why not C? Because C doesn't occur naturally. It's a synthetic polymer, right? So it's A, B, D. Now it says P does not occur naturally, which means P can't be C. Sorry, Q doesn't occur naturally, it's synthetic, so it can't be C. So C option is gone. Now they must have the same linkage. Fat has an ester linkage and nylon has an amide linkage or a peptide linkage, so A is wrong. Fat has an ester linkage and terylene also has an ester linkage, and this is natural and that's synthetic, so B is the correct option. Protein, bilkul, protein is natural and it has the amide linkage, and terylene is synthetic but it has the ester linkage, not the amide linkage, so D is wrong. Moving on. A compound decolorizes. Do you want to, sir, terylene का structure बता दें? Mariam, please watch organic chemistry crash course part 2. You'll find out terylene structure. Organic chemistry part 2, Hanya is present. Fats are a part of your course, just the structure isn't. Everything else is. A compound decolorizes acidified aqueous potassium manganate, which means acidified aqueous potassium manganate is oxidizing agent, and the compound that's going to decolorize it must be what? A reducing agent. So you have to check out which of these is a reducing agent or what can be oxidized. This is a very beautiful question. This is a very beautiful question. Yeah. Magnesium chloride. Magnesium has a charge of 2 plus. Can it further be oxidized? Can magnesium further lose an electron? Oxidation is the loss of electron, right? Can magnesium further lose an electron? It has already lost 2 electrons. Can it further lose an electron? The examiner said almost 90% of the kids got this wrong. No, it can't. So 1 can't be a reducing agent. If you check out 2, it's FeCl2, which means iron has a charge of 2 plus. My question to you guys is, can iron further be oxidized? Can iron further be oxidized? Yes, it can be oxidized. Iron can go from iron 2 plus to iron 3 plus by losing an electron. And that electron which has been lost will be gained by potassium manganate. So absolutely, iron chloride is in fact a reducing agent, and it would react with potassium manganate because it can further be oxidized because it has various oxidation numbers. We know iron has an oxidation number of 2 plus, of plus 2, and then obviously of plus 3 as well. Ethanol. Can ethanol be oxidized? Absolutely it can. Ethanol can be oxidized to ethanoic acid. And how do you do it? Literally, you do it by using acidified aqueous potassium manganate. So 2 and 3 are correct. Therefore, C is the correct option, not D. Pure lead sulfate is prepared by mixing two sulfates. Lead sulfate is obviously an insoluble salt. This question is so hard. Abhi, you haven't even looked at the question, kiddo, and you're saying it's so hard. So it's saying, what are the ways to prepare the lead sulfate? You need to prepare lead sulfate. So you need to take two soluble salts. Probably take lead nitrate and a soluble sulfate. So it says substance X and substance Y. First of all, does crystallization and filtration happen in preparation of insoluble salts? Yeah. No, it doesn't. No, it doesn't. Yes. So A and C, that's absolutely wrong. right? Because crystallization doesn't happen. You just wash the residue, wash and dry the residue, wash and dry the residue. Now, which of these can I take? Should I take aqueous lead nitrate and aqueous sodium sulfate, or solid lead nitrate, lead carbonate? You can't take solid. You need two aqueous solutions. So D is wrong. B is the correct option. Brass is an alloy. Which statement about brass is correct? It contains a sea of electrons. Yes. Remember, brass is a mixture of copper and zinc, right? Brass is a mixture of copper and zinc, and copper is a metal. Zinc is a metal. They'll have delocalized electrons. Absolutely. It's a mixture. What would happen if we took solid D? Nothing would happen because this is solid. It's not aqueous. You're just adding an insoluble solid to acid. Nothing. Oh, no. Something would happen. Why am I saying nothing would happen? Lead carbonate is a weak base. So it'll react. Lead carbonate is going to react with sulfuric acid, H2SO4. It's going to form PbSO4, aqueous, and H2O and CO2. So कुछ तो होगा. Yes, ये होता है. Yeah. But then you need to understand that you wouldn't wash and dry the residue. What would you do? You'd pour this and then crystallize it. But the problem is this is not the accurate way of preparing an insoluble salt. This is how you prepare an insoluble salt. You could have done this and then you could have added to an evaporating dish and heated it till the point of crystallization. But that option isn't shown here. And even if it was shown here, B is the accurate way of preparing the salt. You know? Okay. Moving on forward. Mm-mm. A student wants to show that the rate of reaction between calcium carbonate and dilute hydrochloric acid doubles every 10-degree rise, and you need to write about the apparatus used. Now, see, if you want to measure the temperature, you obviously need a thermometer. Therefore, A is wrong because there's no thermometer present. If you want calcium carbonate, you need to measure its mass. And if you want dilute hydrochloric acid, you need something to measure dilute hydrochloric acid, probably a measuring cylinder or a burette or a pipette, whatever, right? So any would work. Now, it's saying, and if you want to measure the volume of carbon dioxide, you need something to, collect carbon dioxide like a gas syringe or, over water delivery or whatnot. Now it says, which of these apparatus is essential? He's saying the student has a Bunsen burner and a gas syringe. So he has these two things. He also has to heat it up. So Bunsen burner is also needed. What other apparatus does he need? Does he need a balance? Absolutely. And obviously, because he's measuring rate, he needs a clock. Obviously. Now it's saying balance chahiye, yes. Measuring cylinder, yes. Thermometer, yes. Clock, yes. Yes. B is the correct option. Why is C and D not correct? C and D are not correct because there's no mention of a balance here. How do you know how much calcium carbonate you're adding? You need to make calcium carbonate constant. The mass of calcium carbonate that you're adding. Everything else should be constant. If you just want the effect of temperature, you should make sure that everything else is constant. Yeah. Which statement about the structure and bonding of metals is correct? It's a lattice of consists of atoms in a say. No, it consists of a lattice of positive ions, not atoms, positive ions. Because you're talking about bonding. Positive ions. Electrons in a metal move randomly through the lattice. That's why we say they're delocalized. Absolutely, they do. Metals are malleable because particles present are mobile. No, because the layers can slide over each other. If your concepts are good, these MCQs are a piece of cake. The ions in a metal move when positive and negative electrodes are attached. Not the ions, the electrons move. Not the ions. Positive and electrons are negative electrodes are attached, then the electrons are the ones which are moving, not the positively charged ions. Last question of 2018 difficult question set. Brass is an alloy. We've already done this. How difficult was this, to be very honest? I did for the first time with you guys. How difficult? I hope all my answers are correct. They are correct, probably. Above mid, how difficult? It was difficult. What about D? It is a compound of two. It's not a compound, no? It's not a compound. It's a mixture. It contains positive and negative ions. It does not have any negative ions. It has electrons. No, I mean the easy level is above mid. Okay. Sir, one of your MCQ was incorrect. Baki sab. Okay, your one was incorrect. Which of my one was it? 80-20 difficulty. Sir, I have nothing, but still they were easy. I have done nothing. Now I don't know if I'm smart or dumb. No, Hanya, it may have seemed easy because I was doing it. So probably you should have done it on your own first. It was Halwa. Should I opt sciences for CA? Sure, Sanya. I would not recommend CA to any student. No CA. There's no point in doing CA. It's too much work. Too much work. And do you see my eyes? Do something productive. Sir, but you are so rich. I know I'm rich, but But CA is money. Chill, guys. You can't deprive yourself of longevity. सोए chill करें. Are you engaged? No. चलो, take sciences. Did you take a gap year? No. Before giving CA paper? No. Counseling needed? Guys, can you guys just hold up till your O level exams are over? I swear on my life that I'm gonna conduct a counseling session with all of you. I promise. And if you guys, feel very, haphazard about things and you guys are, oh my god, ab kya hoga? You guys can call me. I'll attend it and I'll guide you. Don't worry. But I still recommend, first of all, doing the O levels. I got A stars, Osama. I had like 8 A stars, 2 A's in my O levels. In A levels, I got A stars. Sir, can we MG you too? MG? Mug? What are about the A level phases different? What's the difference between O level and A level? Unknown gamer, there's no difference between O level and A level. Um, A level is easier compared to O levels because they're just literally 3 or 4 subjects that you have to study. I seriously am I think I'm the only teacher, even Sir Abbas says A levels is I think I'm the only teacher who says A level chemistry is easier compared to O level chemistry. I think I'm the only guy who says it. And I'm the only person who says that A level is easier compared to O levels. Because I myself has done it. I found A levels easier compared to O levels. It was a piece of cake. As long as you get a good teacher. In my A levels, because I was a I was a party boy. I used to just party all day, chill out, go to gigs and whatnot. तो मैं फिर आखिर में खुद पढ़ता था. Yeah, I had a 1% attendance. I'm happy they didn't kick me out of the college. I did my levels from HSN College, Mariam. Hania saying I went through the syllabus of A-level physics, chem, and bio. It's not that bad. It is not that bad. We trust you blindly. Never trust anybody blindly. What were your subjects? I had math, chemistry, physics, and computer science. HSN में scholarship मिल जाती है आजकल मिलती है in our time there was no scholarship because they've ended it. I think now they've introduced scholarship. I think they should hire me as a brand ambassador. The amount of promotion that I've done for HSN college. Yeah. I got a star in my chemistry, I got a star in my physics, and got an A in computer science. Yeah, A level math ka uh, has the class ended? Yes. Yeah. I'll guide you all after your O level paper. Should I choose CS if I have not studied in O levels? Only if you have a passion for it. Engineering के लिए chemistry लेना है? Yes, unless you're doing mechanic. No, no. Yes. Chemistry is a must for engineering. Chemistry, math, and physics, pre-engineering subjects. Yeah, architectural engineering, then I don't think so. You have to confirm this from your school. Architectural engineering, I don't think so. I don't think chemistry, but math and physics are compulsory for any type of engineering. Then now there's a choice between chemistry and bio, I think. Depends on what type of engineering you want to do. Should I choose CS if I want to do CS? Sure. Sir, sleep, thanks, Tamur. Do you recommend taking accountings in A levels? Depends on what you want to do. Why didn't you go towards CS? I hated computer science. Sir, is EM a good environmental management? Is just a free grade. It's a good subject because it's a free grade. Should I take computer science if I want to do CA? Yeah, definitely. Definitely. Python is going to help you a lot in the field of chart accountancy. I think I should stop the recording.